See, I changed some numbers around again. How many moles? Okay, I did. Let's get rid of this. I used how many moles is 2.8 times 10 to the 15 atoms of silicon. Number of atoms we have, I have changed that. So the number of atoms, this is what we have, and that's what we call our given. They say what we have. And here, this 1 mole equals 6.02 times 10 to the 23rd atoms, and we use that for our conversion factor. Here we see our conversion factor right here. We start with our given. Let me point to it. Start with our given here. Times 1 divided by 6.02 times 10 to the 23rd. We want atoms to cancel out, so that's why we put this on the bottom. If we had moles here, we would have moles on the bottom. And I have that in a different color. Atoms cancel out. And again, kind of move things around, we would have 2.8 times 10 to the 15 divided by 6.02 times 10 to the 23rd. 2.8 divided by 6.02 gives us 0.465 times 10 to the 15 divided by 10 to the 23rd. 15, remember we subtract top minus bottom, 15 minus 23 equals minus 8. So that's times 10 to the minus 8. Okay, the 15, 23 are the exponents. Now again, we need that 4.65 in the correct. We want 4.65, not 0.4. This is the first answer I get. And so we move it over, and that becomes a minus 9. So this is the correct answer. If you have multiple choice, they might not put this one in. They might put this one in. Okay. Again, let's just take this 4.465 0.465, and if we want that 4.65, that's times 10 to the minus 1. We put a negative number when these are less than 1. And so it's 10 to the minus 1 plus 10 to the minus 8, so that's how I got 10 to the minus 9. I did this as a separate problem, and then I still had that times 10 to the minus 8. And then that's where I got 4.65 times 10 to the minus 9. Okay, so that's atoms to moles. Next one, going from moles to mass. And if we look at our little road, okay, from mass to moles, we use the molar mass to convert. Okay, we use this molar mass to convert this way or this way, depending on which direction you're going. And I can send you these slides. So here, what is the mass of 9.45 moles of aluminum oxide, Al2O3? So this is what we're looking for. We know we have to add up the molar mass of aluminum. We have 2 aluminums, 2 times 27. We looked that up in the periodic table is the mass of aluminum, plus 3 times mass of oxygen, plus 3 times 16. So 1 mole of aluminum equals 102 grams. Okay, this is going to be our conversion factor. Again, just like 1 hour equals 60 minutes. This is how I convert between moles and mass. So we start with our given. See moles here? We want moles down here so they cancel out. And then we just do the math. This times this equals this. Grams are left over just like XY in X and Y in algebra. We always use units. This is on the bottom, it's a divide, so it's this times this divided by this. And this is what we get. Okay, so this is the mass over moles, and let's flip back to that. Whoops. Okay, we're going from mass to moles. Oh, here, no, we were going from moles to mass. And whoops, what happened there? Okay, so we were given moles, we were asked for mass, and then we would have the molar mass on top. If we were going given mass and asked for moles, we would have the molar mass on the bottom. And here's one where we're going to do that. Okay, how many moles of iron 3 oxide are contained in 92.2 grams of pure iron oxide? So we're looking for moles. You always write down what you're given and what you're looking for. This is what we're given. We're given 92.2 grams. We have to find the molar mass of iron. We have 2 irons, so 2 times the mass of iron plus 3 times the mass of oxygen equals this. And this is what we use for our conversion factor. I'll box it in. 1 mole of Fe2O3 equals 159.6 grams. Again, I calculated that. 2 times the mass of iron plus 3 times the mass of oxygen. I got these numbers here in the periodic table. So I start with grams. I want grams on the bottom. Okay, I want grams on the bottom to cancel out. I want moles as the answer. So this is 92.2 times 1. Anything below this line, you hit the divide button. So 92.2 divide by 159. Even though it says times, that's times 1, but on the bottom, anything below that line, you divide. And you get this number. So 92.2 divided by, if 1 mole is 159, 92 is going to be less than 1 mole. Probably a little more than half. It seems to make sense. So here, this is going from grams to moles. Grams to moles. And if we look back on this, we're going from grams to moles, so we use this one. Now, the last one is mole and volume. Avogadro hypothesis, equal volumes of gases at the same temperature and pressure contain equal number of particles. Can I do all of them? Yeah. So when you're given a gas, when they talk about volume, that's in liters. This one is easy because you don't have to do any calculating. Well, you don't have to add grams. For everything, when they talk about liters, 1 mole equals 22.4 liters. If I would weigh out 1 mole of dry ice and put it in a bag and close the bag, the garbage bag, and let it go to the gas, this carbon dioxide, it would be the volume of 22.4 liters. So that makes it easy for any of these volumes. When we talk about volume, it's in liters. If you see a question that talks about liters, you're going to use this type of conversion. So we start with moles, and here is our conversion factor. We want moles on the bottom, and then we multiply. 0.6 times 22.4, so 0.6 moles of sulfur dioxide is 13.4 liters. Again, you have to look at the units. If they're talking liters, you have to use this. If they're talking grams, you have to find the molar mass. And if they're talking atoms or molecules, you use Avogadro's number. And let's see. Whoops. And that's it for this.